A wire of length 28 meters is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the circle and the square is minimum? Combined area of the circle and the square is minimum. A wire of length 28 meters is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. Let X be the side of the square and R be the radius of the circle that has been cut from this wire. Then the length of two pieces is equal to, one piece will be equal to perimeter of the square and the other will be circumference of the circle. Then sum of the lengths of these two pieces is given to be 28. Length of wire is equal to 28 meters. Therefore, perimeter of square plus circumference of circle is equal to 28 meters. Side of square is x. Therefore, perimeter of square is 4x plus circumference of the circle. Radius of the circle is r. Therefore, circumference of circle will be 2 pi r. This must be equal to 28 meters. Now, what should be the length of the two pieces so that the combined area of the circle and the square is minimum? Combined area is equal to area of this circle. Area of circle is pi r square and area of square is x square. Let us call this as 1 and this as 2. Now 1 implies 2x plus pi r is equal to 14 and this implies x is equal to 14 minus pi r, 14 minus pi r by 2. That is 1 by 2 of 14 minus pi r. Substituting in 2 combined area, let us call this combined area as A. Then A is equal to pi r square plus x square. This will be 1 by 4 into 14 minus pi r whole square. Now we find dA by dr. We have to minimize this area. So we find dA by dr. This will be 2 pi r plus 1 by 4 into 14 minus pi r. Differential of this will be 2 into 14 minus pi r. 2 into 14 minus pi r into differentiation of inner function. Differential of this is 0 and differential of this will be minus pi. And this is equal to 2 pi r plus this is 1 by 2 into 14 minus pi r into minus pi. And this is equal to pi will be common, so we get pi 2r minus 1 by 2 into 14 minus pi r. This is equal to pi by 2 into 4r minus 14 plus pi r. This is equal to pi by 2 into 4 plus pi into r minus 14. Therefore, dA by dr is equal to 0 implies r is equal to, take this to the other side. This will be 14 over 4 plus pi. So r must be equal to 14 over 4 plus pi. Now we will show that this is a point of minima. So to show that this is a point of minimum, we find d2a by dr square. d2a by dr square is equal to dA by dr is this much. So second derivative of this. This will be pi by 2 into differential of this is 4 plus pi. And differential of r is 1. And differential of this is 0. So we get pi by 2 into 4 plus pi, which is positive. Therefore, d2a by dr square at r is equal to 14 over 4 plus pi is greater than 0. This is equal to this, which is positive. Therefore, r is equal to 14 over 4 plus pi is a point of minimum. And therefore, the combined area will be minimum if r is equal to this much. And therefore, length of two pieces is equal to length of two pieces is equal to perimeter of square and circumference of the circle. Length of one piece will be equal to perimeter of the square, and the length of the other piece will be circumference of the circle, that is 2 pi r. This is equal to, now 3 implies x is equal to 1 by 2 of 14 minus pi r. Therefore, this will be 4 into 1 by 2 into 14 minus pi r. This will be pi into r. R will be 14 over 4 plus pi. And 2 pi r. 2 pi r. That is 2 pi into r. R is 14 over 4 plus pi. Now we will simplify this. You can see the previous sheet on the side. This is equal to 4 into, this is 1 by 2 into LCM of this will be 4 plus pi. So this will be 14 into 4 plus pi minus 14 pi. And the other piece will be of length 28 pi over 4 plus pi. 2 pi into 14 over 4 plus pi is 28 pi over this. And this is equal to 2 cancels. We get 2 into, this will be 14, 4s are 56. 56 plus 14 pi minus 14 pi whole divided by 4 plus pi, and 28 pi over 4 plus pi. This is equal to, these two cancel, we get 112 over 4 plus pi and 28 pi over 4 plus pi. Therefore, combined area will be minimum if lengths of two pieces are 112 over pi plus 4 and 28 pi over 4 plus pi. Now this question you can try yourself. A wire of length 36 meters is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the circle and the square is minimum? You can try this question on similar lines. Now next question is, show that a cylinder of given volume which is open at the top. Let this be the cylinder. This is open at the top. Show that a cylinder of a given volume which is open at the top has maximum total surface area. Now first is volume is given. Let this be R and this height be H. V is equal to pi R square H. Volume of the cylinder is pi R square H. And surface area, show that a cylinder of given volume, this is given, which is open at the top, has minimum total surface area. This is open at the top. Therefore, surface area of the remaining portion will be, surface area of this circumference will be 2 pi R. 2 pi R is the circumference of this circle. 2 pi R into H will be the surface area. 2 pi R into H is the surface area of this curved portion, plus surface area of this circle will be pi R square. This is pi R square, and this is open, therefore we will not take this circle. So surface area will be surface area of this curved portion plus this circle. Now let this be 1 and this be 2. Now we have to minimize this surface area subject to this condition. So what we do is we express this as a function of a single variable. 1 implies H is equal to V by pi R square. Therefore S is equal to 2 pi R into V by pi R square plus pi R square. This pi cancels with pi and R cancels with R, and we are left with, this is 2V by R plus pi R square. Now this has been expressed in terms of a single variable. So what we do is we find ds by dr. This is equal to minus 2v by r square. Differential of 1 by r is minus 1 by r square, and differential of this will be 2r. So this will be 2 pi r. Therefore ds by dr is equal to 0 implies 2v by r square is equal to 2 pi r, and this implies r cube. Take this to the other side. 2 cancels and we get r cube is equal to v by pi. This is equal to v by pi, and this implies r is equal to v by pi to the power of 1 by 3. Now we will show that this is a point of minimum. So we find d2s by dr square. d2s by dr square is minus, now differential of this will be minus 2v is constant, and differential of r to the power of minus 2 is minus 2 by r cube, minus 2 r to the power of minus 3, plus differential of this will be 2 pi. Differential of this is minus 2v over differential r to the power of minus 2 is minus 2 r to the power of minus 3, minus 2 r to the power of minus 3 plus 2 pi. This is equal to 4v by r cube plus 2 pi, but r cube is v by pi, so r cube is v by pi, so this is positive. Therefore, d2s by dr square at r is equal to v by pi to the power of 1 by 3 is equal to 4v over r cube is v by pi. R is v by pi to the power of 1 by 3, therefore r cube is v by pi plus 2 pi. So v and v cancel, we get 6 pi, which is greater than 0. Therefore, r is equal to v by pi to the power of 1 by 3 is a point of minimum. Is a point of minimum. And we have to show that a cylinder of given volume which is open at the top has minimum total surface area. That is, this is minimum provided its height is equal to the radius of its base. Now we know for minimum r is this much, or r cube is v by pi. For minimum r cube is v by pi, and we have to find the relation between its height and radius. So what we do is we eliminate v. So this implies r cube is equal to, put the value of v. V is pi r square h. This is pi r square h over pi. Pi cancels, r square cancels with this, and we get r is equal to h, provided its height is equal to the radius of its base. We have to prove that surface area is minimum if height is equal to radius of its base. Hence proved. Or we can also proceed as r is equal to this much. So you can directly find h and prove that h is equal to r. So from 1, h is equal to v by pi r square. This is equal to v over pi into r square. R square will be v by pi to the power of 2 by 3. And this is equal to v by pi. This is equal to v by pi to the power of 1 minus 2 by 3. That is v by pi to the power of 1 by 3, which is equal to r. You can also prove that radius is equal to height using this. For minimum, r is this much, and height will be then equal to this, which is equal to radius. Either you proceed in this manner, or for minimum r is this much, and for minimum h will be this much. Now next question is, show that the height of the closed cylinder of given surface area. Now cylinder is closed. This cylinder is closed. Its surface area will be surface area of this curved portion will be 2 pi r h plus surface area of these two circles will be 2 pi r square. So this is 2 pi r into h plus r, and volume of the cone is v is equal to pi r square h. Now we have to minimize s subject to this condition. From here find h is equal to v by pi r square, and put it here. We will get a function of single variable. Now differentiate ds by dr and equate it equal to 0 to get the point and complete the question. You can try it yourself. Next question is, an open tank with a square base and vertical sides is to be constructed from a metal sheet so as to hold a given quantity of water. Show that the cost of the material will be least when the depth of the tank is half of its width. An open tank with a square base. The base of the tank is square. Let this be the tank. The base of the tank is a square. Let its side be x. This is x. This will also be x. This side is x and this side will also be x, since it is a square. An open tank, and this top is open. An open tank with a square base and vertical sides is to be constructed from a metal sheet so as to hold a given quantity of water. Let the height of this tank be y. Then V is equal to, how much is the volume? Volume of this cuboid is x square into y. An open tank with a square base and vertical sides is to be constructed from a metal sheet so as to hold a given quantity of water. How much quantity of water will this tank hold? It will hold quantity of water equal to its volume. So V is equal to this is fixed. It is given. Show that the cost of the material will be least when the surface area of this tank is minimum. Minimum of material is used to construct this tank. Then its cost will be minimum. So we have to minimize the surface area. Surface area is surface area of this base. This base is x square. And area of this side, back. This side will be x into y. This side will be x into y. Front will be x into y. This side will be x into y. So 4 sides of area x into y plus 4x y. So we have to minimize s subject to the condition this. So let this be 1, this be 2. You have to maximize s using this. So use this to express this as a function of a single variable. And then proceed as usual. You complete this question. Next is, show that of all the rectangles inscribed in a given circle. A circle is given and we have to inscribe a rectangle in this circle. Let this be the rectangle. Let this be the circle and this be the rectangle inscribed in this circle. We have to show that of all the rectangles inscribed in a given circle, the square has the maximum area. Area of this rectangle is maximum if it is a square. So let us join this diagonal. Then this must pass through the center of the circle. Let O be the center of the circle. This be A, this be B, this is C, and this is D. Let A be the radius of this circle, which is fixed. Circle is given. So length of this diagonal will be 2A. Length of this diagonal will be 2A. Let this angle be theta. Let this angle be theta. Sine of theta will be BC upon this. Therefore, this side will be 2A sine theta. This side BC will be equal to 2A sine theta. Because sine of theta will be equal to BC over 2A. Perpendicular over hypotenuse. So BC will be 2A sine theta, and this side will be AB will be equal to 2A cos theta. 2A cos theta. Cos of theta will be AB over 2A. So AB will be 2A cos theta. Cos theta will be equal to AB over 2A. Therefore AB will be 2A cos theta. So this is 2A sin theta and this is 2A cos theta. Now first part is the square has the maximum area. We have to maximize the area of this rectangle. A is equal to, now area of this rectangle will be length into breadth. That is 2a cos theta into 2a sin theta. This is equal to 4a square sin theta into cos of theta. This can be written as 2a, 2 sin theta cos theta is sin of 2 theta. And this theta lies between 0 and pi by 2. This theta 0 is less than theta is less than pi by 2. It cannot be 0. If this angle is 0, then this side will also be 0. There will be no rectangle. And if it is pi by 2, then this side will be 0. So theta lies between 0 and pi by 2. Now we have to maximize A. We have to maximize A. What we do is we find dA by d theta. dA by d theta is equal to 2a square. Differential of sine is cos of 2 theta into differential of inner function is 2. That is 4a square cos 2 theta. Therefore dA by d theta is equal to 0 implies cos of 2 theta is equal to 0, and this implies 2 theta is equal to pi by 2. 2 theta is pi by 2. This implies theta is equal to pi by 4. Now to check whether this is a point of maximum or minima, we find d2a by d theta square. d2a by d theta square is from 1, it is 4a square. Differential of cos is minus sine 2 theta into 2. That is minus 8a square sine 2 theta. Minus 8a square sine 2 theta. Therefore d2a by d theta square at theta is equal to pi by 4. d2a by d theta square at theta equal to pi by 4 is minus 8a square sine of 2 into pi by 4. That is pi by 2. That is minus 8a square, which is negative. Therefore, theta is equal to pi by 4 is a point of maximum. This is a point of maximum, and therefore AB is equal to 2a cos pi by 4. That is 2a 1 by root 2. That is root 2a, and BC is equal to 2a sine pi by 4, which is equal to root 2. Therefore AB is equal to BC. Therefore ABCD is a square. Therefore for maximum area the rectangle must be a square. Therefore for the rectangle inscribed in a given circle has maximum area when it is a square. An alternative method to solve the same question can be, let this be x and this be y. Therefore this is also y, this is x. Then area of this rectangle is length into breadth, x into y. Now this is a function of two variables. Now to express it as a function of a single variable, we need another relation. So what we know that this rectangle is inscribed in a given circle. Therefore this must be equal to the diameter of the circle. Therefore x square plus y square must be equal to 2a square. This must be a right angled triangle. And therefore from triangle ABC, x square plus y square must be equal to 4a square. Now we will use this to express 1 as a function of a single variable. Now y is equal to under the root 4a square minus x square. Therefore, a is equal to x into under the root 4a square minus x square. Therefore, dA by dx is equal to first function into differential of this. Differential of this will be 1 by 2 4a square minus x square into differential of inner function. Differential of inner function is minus 2x. Differential of this is 0 and differential of this will be minus 2x plus under root 4a square minus x square into differential of this will be 1. First function differential of second plus second function differentiation of first. This is equal to, now take the LCM. LCM is, now this 2 cancels with this and LCM is 4a square minus x square. So this is equal to minus x square and plus 4a square minus x square. This into this will be 4a square minus x square. This is equal to minus 2x square plus 4a square whole divided by under the root 4a square minus x square. Therefore, dA by dx is equal to 0 implies 2x square is equal to 4a square, and this implies x is equal to 2 cancels and we get x is equal to root 2a. For maximum area, x must be equal to root 2a. That is, length must be equal to root 2a. And to prove that this is a point of maximum, we use first derivative test. What we do is, for x less than root 2a, we find the sign of the first derivative, dA by dx. And for x greater than root 2a, we again find the sign of dA by dx. X is less than root 2a, therefore x square is less than 2a square. X square is less than 2a square. Therefore 2x square will be less than 4a square. This will be less than 4a square. Therefore this will be positive. Is positive. And when x is greater than root 2a, therefore x square is greater than 2a square. X square is greater than 2a square. Therefore 2x square is greater than 4a square. So this is greater than 4. Negative quantity is greater than 4a square. Therefore this will be negative. So the sign changes from positive to negative. That is, the function changes from increasing to decreasing. That is, rising to falling. Therefore it will be a point of maximum. Therefore x is equal to root 2 is a point of maximum. And for x equal to root 2a, y will be equal to, from 3, y will be equal to, y is equal to under root 4a square minus x square. X square will be 2a square. So this is equal to 2a square under the root. That is root 2a. Therefore x is equal to y. Therefore length is equal to breadth. Therefore it must be a square. This approach can also be followed. But I think this is simpler. But you must know both of these. In some questions you can use this, in some. So you must have this approach also in your mind. Next question is, find the volume of the largest cylinder that can be inscribed in a sphere of radius a. Let this be the sphere of radius a, and let this be the cylinder inscribed in this. Let us join these two ends. Let this angle be theta. Then this is equal to the diameter of the cylinder. Then this is the diameter of the sphere. And diameter of the sphere is 2a. Radius is given to be a. So diameter is 2a. And therefore this side must be equal to, let this be A, this be B, this be C, this be D, and this be the center of the sphere. Let this be O. Now BC over hypotenuse is sine of theta. Therefore BC must be equal to 2a sine theta. And AB upon hypotenuse is cos of theta. Therefore AB must be equal to 2a cos theta. So AB is 2a cos theta and BC is 2a sine theta. Find the volume of the largest cylinder that can be inscribed in a sphere of radius a. Now volume of the cylinder is equal to pi r square into height. This is equal to pi into r square. Radius is half of AB. So half of AB is a cos theta. This is a cos theta. Radius square into height. Height is BC. BC is 2a sine theta. This is 2a sine theta. Therefore this is equal to 2a cube into pi cos square theta sine theta. And we have to maximize the volume. We have to maximize V. We have to maximize V. So what we do is we find the first derivative. dV by d theta is equal to 2a cube pi into first function into differentiation of second. Differentiation of sine is cos theta plus second function, that is sine theta, into differentiation of this. Differentiation of this is 2 cos theta into differentiation of cos is minus sine theta. This is equal to 2a cube pi into cos of theta is common. Cos theta is common and we are left with cos square theta minus 2 sine square theta. 2 sine square theta. And this can be written as 2a cube pi into cos theta into. Now change this into sine. This will be 1 minus sine square theta. So this will be 1 minus 3 sine square theta. And this theta lies between 0 and pi by 2. 0 is less than theta is less than pi by 2. Now to maximize this, we put dV by d theta equal to 0. And this implies either cos theta is 0 or 1 minus 3 sine square theta is 0. And this implies either theta is equal to pi by 2, rejected, because theta lies between 0 and pi by 2, or sine square theta is equal to 1 by 3, or sine of theta is equal to 1 by root 3. This is 1 by root 3. 1 can also be written as dV by d theta is equal to 2a cube pi cos theta into 1 plus root 3 sine theta into 1 minus root 3 sine theta. Now theta lies in first quadrant. Therefore this is positive, this is also positive. Sine theta is positive in first quadrant. So the sine of dV by d theta will depend only on this. We use first derivative test to check whether this is a point of maximum or minimum. Theta is equal to sine inverse 1 by root 3. Now we find the sine of dv by d theta for theta less than sine inverse 1 by root 3. For theta less than sine inverse root 3 and for theta greater than sine inverse 1 by root 3. Now d by d theta of sine theta is cos theta, which is positive in first quadrant. That is, when theta lies between 0 to pi by 2, this will be positive. Therefore, sine theta is monotonically increasing. Therefore, alpha less than beta will imply sine alpha is less than sine beta. Because it is monotonically increasing, therefore this trend will be maintained. If alpha is less than beta, then the value of sine alpha will also be less than sine beta. You can also consult the graph of the sine function. From 0 to pi by 2, it is rising. Therefore, it is monotonically increasing. Or you can find the first derivative, and since first derivative is positive, therefore it is monotonically increasing. And therefore, alpha less than beta will mean sine alpha is less than sine beta. And therefore, this will imply that theta is less than this. Therefore, sine of both sides will also be less than this. Trend will be maintained. If I take sine theta of both sides, this trend will be maintained. That is, sine theta will be less than sine of sine inverse 1 by root 3. That is, sine theta is less than 1 by root 3. This will be less than 1 by root 3. This implies root 3 sine theta is less than 1. And this implies 0 is less than 1 minus root 3 sine theta. Therefore, this is positive. Therefore, dv by d theta is positive. This implies dv by d theta is positive. Now we take theta is greater than sine inverse 1 by root 3. Now take sine both sides. Therefore, sine of theta is greater than sine of sine inverse 1 by root 3. Sine is a monotonically increasing function in first quadrant. Therefore, alpha is less than beta will imply sine alpha is less than sine beta. That is, this trend is maintained. This is greater than this, therefore trend will be maintained. And therefore, this implies sine of theta is greater than 1 by root 3. Theta is greater than 1 by root 3. And this implies root 3 sine theta is greater than 1. And this implies 1 minus root 3 sine theta. Take this to the other side. This is less than 0. Now in first quadrant, this is positive, and this is negative. Therefore, dv by d theta is negative. Therefore, what we note is dv by d theta changes its sign from positive to negative as we increase past sine inverse 1 by root 3. It changes its sign from positive to negative. That is, from monotonically increasing to monotonically decreasing. That is, rising to falling. And therefore, theta is equal to sine inverse 1 by root 3 is a point of local maximum. we have to find V maximum. Now V maximum is equal to, now V is 2a cube pi from 2a cube pi cos square theta into sine of theta at theta is equal to sine inverse 1 by root 3. That is, theta is equal to sine inverse 1 by root 3 implies sine of theta is equal to 1 by root 3. And this is equal to 2a cube pi whole into. Now cos can be written as 1 minus sine square. 1 minus sine square theta into sine of theta. This is equal to 2a cube pi into 1 minus sine square. Sine square will be 1 by 3 into 1 by root 3. So this is 2 by 3. So this is 2 2s are 4. 4 by 3 root 3 pi a cube. This is the answer.